Hello students, welcome back to my video classes. In the previous class, we did problems on limit comparison test and we are left with a few more problems. So we will complete the rest of the problems in this class. Problems from 8 to 13 are all similar. In all these questions, there is square root, either square root or cube root. So from the numerator, if square root or cube root is there, we have to multiply with its conjugate and see that that surd does not exist in the numerator. So we'll do the problems and understand. Among these 6 questions, we'll do questions 8, 9, 11 and 12. So question 9 has cube root and the rest of all are square roots. So let us start 8th one. What is un here? Let un is equal to square root of n plus 1 minus root n. So I already told you, if square root or cube root is present, we have to rationalize it with its conjugate. So for root a minus root b, its factor is, conjugate factor is root a plus root b. So after multiplying, this will become a minus b. So for this, it is root n plus 1 minus root n. Its conjugate is root n plus 1 plus root n. So multiply both in the denominator and in the numerator. So this will be root a minus root b into root a plus root b is equal to root a whole square minus root b whole square, that is equal to a minus b. So simply n plus 1 minus n by root n plus 1 plus root n. So n gets cancelled in the numerator. This will be equal to 1 by root n plus 1 plus root n. So our un is simplified into this form. Now there is no root in the numerator. So we can proceed as usual as we did in the previous problems. So take vn as the highest power in the numerator for n is 0. So I'll take as 1. For the denominator it is n power 1 by 2 and n power 1 by 2. So it is n power 1 by 2, which is root n. So this will be our Vn. So Vn is 1 by root n. So we know that this is divergent. Summation Vn is divergent by P series test. Why it is divergent? Root n means n power 1 by 2. So by P series test, if P is less than or equal to 1, it is divergent. So 1 by 2 is less than or equal to 1. So this is divergent. Now let us calculate limit of un by vn. This is equal to limit of un is 1 by root n plus 1 plus root n by vn is 1 by root n. So taking this to the numerator, we have root n by 1. So taking highest power of n common, root n is there in the numerator, and for the denominator it is taking n common from this, n will come out as root n, and this will become 1 plus 1 by n, plus taking root n common from this will become 1. So root n gets cancelled. This is equal to limit 1 by root 1 plus 1 by n plus 1. So applying the limit, we have 1 by root 1 plus 0 plus 1, which is equal to 1 by 1 plus 1, 2, and is not equal to 0. So therefore by comparison test, limit comparison test, given series summation un is also divergent because the assumed series is divergent. The taken series is divergent. Now the next question. So this question has cube root in the numerator. So take un as cube root of n cube plus 1 minus n. So what is this? Its conjugate. So this can be written as, we have a power 1 by 3 minus b power 1 by 3. If we have this, its conjugate is a power 2 by 3 plus a power 1 by 3 into b power 1 by 3 plus b power 2 by 3. So this question is in this factor, in the form of this factor. We have to multiply numerator and denominator with this one, so that this will become a power 1 by 3 whole cube minus b power 1 by 3 whole cube, which is a cube minus b cube form. So finally you will get a minus b. So we have to multiply with this factor. So what is b here? A means n cube plus 1 power 1 by 3. So a is n cube plus 1. What about b? So this, from this we can write as, this n can be written as n cube power 1 by 3. So this is our b, n cube is our b. So n cube power 1 by 3. So let us now write this by multiplying with its conjugate. So n cube plus 1 power 1 by 3 minus n cube power 1 by 3. Its conjugate is a power 2 by 3, means n cube plus 1 power 2 by 3 plus a power 1 by 3, means n cube plus 1 power 1 by 3, and b power 1 by 3, means n cube power 1 by 3 plus b power 2 by 3, means n cube power 2 by 3. So the same factor should be given in the denominator, n cube plus 1 power 2 by 3 plus n cube plus 1 power 1 by 3 into n cube power 1 by 3 plus n cube power 2 by 3. So I'll erase this. So now this will become, the numerator will become n cube plus 1 minus a minus b, n cube plus 1 minus n cube. The denominator will be same. So n cube plus 1 power 2 by 3 plus n cube plus 1 power 1 by 3 into n plus n power 3, 3 gets cancelled, n power 2. So n cube gets cancelled. So in the numerator 1 is left. So in the denominator I'll take n cube common. Whatever common is there, the highest power, that I'll take as common now itself, instead of doing in the next step. So what is highest power here? Here highest power is n square. In this, what is the highest power? Already n is there. So from this, if I take n common, n cube outside, so taking n cube outside, it will come out as n cube power 1 by 3. 3, 3 gets cancelled. So this n cube, if you take outside, it will come out as n. Already n is there here. So n and n I can take common. That is n square I can take common. From this also, from the third term also, I can take n square common. From this term also I can take n square common. If I get n cube outside, this will become n cube power 2 by 3. That implies this is equal to n square. So from all the three terms, n square is common. So I'll take n square common from all the three terms. So first term will become 1 plus 1 by n cube power 2 by 3. Second term will become 1 plus 1 by n cube power 1 by 3. Third term will be 1. So instead of taking this common in the next step while we applying limit, now itself I have taken. Now what is the Vn that we have to take? Take Vn is equal to, so 1 by n square, highest power in the numerator, nothing. So 1 by in the denominator n square. So 1 by n square. And we know that summation Vn, which is equal to summation 1 by n square, is convergent by P series test. So now take the limit of un and un by Vn. So limit of un by Vn is, so this is our un and this is our Vn. So if I divide un by Vn, 1 by n square gets cancelled and only this factor is left. So limit of 1 by 1 plus 1 by n cube power 2 by 3 plus 1 plus 1 by n cube power 1 by 3 plus 1. So applying the limit, 1 by n will become 0. So this is equal to 1 by 1 power 2 by 3 plus 1 plus 0 power 1 by 3. So 1 power 1 by 3 plus 1. So because we are taking only real values, so all will be equal to 1 plus 1 plus 1. So this is equal to 1 by 3 and is not equal to 0. Therefore, by limit comparison test, our given series is also convergent. Summation un is also convergent. So questions 10 and 12 are left to you. Let us do 11 and 13. So for question 11, what is un? Let un is equal to square root of n square plus 1 minus n. So rationalizing this, we multiply with its conjugate, so which is root n square plus 1 plus n, both in the numerator and denominator. So this will become root n square plus 1 whole square minus n square by root n square plus 1 plus n. So root, this will get cancelled. So I'll write directly here only. Now n square gets cancelled. So this will become 1 by root n square plus 1 plus n. So there is no root involved in the numerator. So we can proceed. Take Vn is equal to, so what will be the Vn? Highest power, there is no n involved in the numerator. So 1 by n power, highest power is, here it is n square power 1 by 2, which is n. Here also it is n. So 1 by n will be our Vn. 1 by n, which is convergent or divergent? This is divergent by T series test. Summation 1 by n is divergent by T series test. So now limit of un by Vn, which is equal to limit of un is 1 by root n square plus 1 plus n by Vn is 1 by n. So taking this to the numerator, we have n by 1. So taking n common from both in the numerator and denominator and getting cancelled, 1 by, taking n square outside, this will be coming out as n. So 1 plus 1 by n square. That n will get cancelled with the numerator, plus taking n common, we are left with 1. This will get cancelled with the numerator n. So this we got. That is equal to, so taking 1 by n as 0, replacing 1 by n with a 0, this will be equal to 1 by root 1 plus 0 plus 1, which is equal to 1 by root 1 plus 1. Root 1 has two roots, square root of 1. 1 plus 1. We are taking only positive roots. 1 plus 1, which is equal to 1 by 2, which is not equal to 0. Therefore, both behave alike. Therefore, by limit comparison test, summation un is also divergent. So the next question, 13th one. Here un is, let un is equal to square root of n power 4 plus 1 minus square root of n power 4 minus 1. So these are square roots. So multiply with its conjugate. This will become square root of n power 4 plus 1 minus square root of n power 4 minus 1 into square root of n power 4 plus 1 plus square root of n power 4 plus minus 1 by square root of n power 4 plus 1 plus square root of n power 4 minus 1. This is equal to, the numerator becomes n power 4 plus 1 minus n power 4 minus 1 by square root of n power 4 plus 1 plus square root of n power 4 minus 1. So n power 4 gets cancelled in the numerator. This will become 1 minus of minus 1 is plus 1. 1 plus 1 is 2 by the denominator is n power 4 plus 1 plus root n power 4 minus 1. So there is no root involved in the numerator. So we can proceed. Take Vn is equal to, what will be our Vn? The highest, there is no n factors in the numerator. So taking 1 in the numerator and in the denominator it is n power 4 with the square root is the highest one. So square root of n power 4, which is equal to n square. So let us take Vn as 1 by n square. So summation Vn is convergent by P series test. So therefore limit of un by Vn, which is limit of un is 2 by square root of n power 4 plus 1 plus square root of n power 4 minus 1 by Vn is 1 by n square. So taking this to the numerator into n square by 1. So this is equal to limit. So take n power 4 outside common. It will become n square and it will get cancelled with the n square in the numerator. So we will have 2 by square root of 1 plus 1 by n power 4 plus square root of 1 minus 1 by n power 4. Right? This will be equal to, applying the limit, 2 by root 1 plus 0 plus root 1 minus 0. So this is equal to 2 by 2, which is 1 not equal to 0. Therefore, by limit comparison test, summation un is also convergent. Finally, we are left with these 4 problems. These 4 problems are not based on limit comparison test. These are based on the points that we have discussed earlier. What are those points? If summation un converges, then limit of un must be 0. If limit of un is not 0, then summation un should be divergent. It diverges. So let us do one by one. So what is question 14? Summation log 1 by n. I can write this as summation log n power minus 1. So minus will come here to the left side of log n. So minus log n. So minus is there to every term. It is involved in every term. So I'll take minus outside and write summation log n. So log n is our un here. So we know that limit of log n is definitely not going to be 0. Actually it is infinity. So it is not equal to 0. So from this second point we can say that summation un is divergent. That means summation log n is divergent. Since summation log n is divergent, minus summation log n is also divergent. That means summation log 1 by n is also divergent. So what about 15th one? 15th one is based on, this question is based on comparison test. So what is, we know that log n will be greater than 1 for sufficiently large n. Say there exists m belongs to n such that log n is greater than 1 for all n greater than or equal to m. We know this. So we will use this to prove this one, and by using comparison test. So we know that there exists m belongs to n such that log n is greater than 1 for all n greater than or equal to m. So taking the reciprocals, 1 by log n is less than 1 for all n greater than or equal to m. Here we have 1 by n square into log n. So multiply with 1 by n square both sides. 1 by n square log n is less than 1 by n square for all n greater than or equal to m. So now by looking at this, it is of the form un less than vn, and series vn is convergent. 1 by n square is convergent by p series test. So un must be convergent by comparison test. So by comparison test, summation 1 by n square log n is convergent. So we have applied a comparison test here. And third one, next question, 16th one. So by looking at this only, you can say that the limit of this is e not equal to 0. So by this second point, we say that that is divergent. So limit of un, which is equal to limit of 1 plus 1 by n power n. We know that this formula is 3e. So it is not equal to 0. So that implies summation un is divergent with by this point. And the last one, 17th one. So given un is log 1 plus 1 by n. So by looking at this, log 1 plus 1 by n, if there is n in the power, by taking limit, this will become e. So we try to get n in the power of 1 plus 1 by n. How we can get that? So this, if here n is there, it will come here before log. So it will become 1 n times log. So try to get n here. How can we get that n? By taking Vn as 1 by n. So if you take Vn as 1 by n, this will come to the numerator, n will come to the numerator. and goes to the power of this factor. So take Vn is equal to 1 by n in this case. So take Vn is equal to 1 by n, and summation Vn is divergent by P series test. Now we can able to calculate the limit. So limit of Un by Vn, which is equal to limit of log 1 plus 1 by n by 1 by n. So 1 by n will go to the numerator and becomes n by 1, which is n times 1 plus n times log 1 plus 1 by n. That is equal to limit of 1 plus 1 by n power, sorry, I'm forgetting log, limit of log 1 plus 1 by n power n. This will be equal to, this is equal to e. So it is log e. So limit goes inside. So limit of log 1 plus 1 by n is log e, which is equal to, we can say 1 if it is ln, but this is not equal to 0. Therefore, by limit comparison test, our series summation un is divergent. So that's all from limit comparison test and its problems. We